Hi everyone, welcome to Mr. Wagid's math class. Today we will be talking about transformation, but this time we are not transforming a figure in a coordinate plane, we are transforming an equation. As a reminder, transformation is the umbrella, and under it are the 4 different ways to transform a figure in a coordinate plane. The first one is translation, which means sliding. Left, right, up or down, some distance. The rule is to add and subtract the same number from both x and y. Reflection is a flip over a line of reflection. It could be the x-axis or the y-axis or any other line. If you change the sign of the y, that's a reflection over the x-axis. If you change the sign of the x, that's a reflection over the y-axis. Rotation is a turn, some degrees, and some direction, like 90-degree, clockwise, counterclockwise, and so forth, but we will not be discussing this today. The last one is dilation, and you can dilate a figure by enlargement if you multiply each coordinate by a scale factor that's more than 1, which is the k, and it's a reduction if you multiply each coordinate by a scale factor between 0 and 1. So it's less than 1, but more than 0 because it can be a negative number. For today's lesson, we are not transforming a figure in a coordinate plane. We are transforming lines in a coordinate plane or equations in a coordinate plane. So you know how to transform a figure. The only 2 things I wanted to talk about is a horizontal and vertical. So if we make any horizontal changes, which means we take this and go horizontally this way, isn't that the x-axis? Because the x-axis is a horizontal line. So any change, horizontal change, that means a change to the x. Now let's go back. Any vertical change, and you can see the change because I'm only changing one line. I'm not changing the whole figure. Vertical change, which means a change to the y-axis. The only one thing I want you to also remember that we don't use y anymore or the output, we use f of x. So f of x is the y and x is still x, which is the input. Here's one more thing for today's lesson, something called family of function. If you know what a family is, and everybody knows what a family is, parents and kids. The parents are called the parent function, and the kids are the new functions, if you think of it that way. They hold similar characteristics. Now let's talk about family of function in equations. They are a group of functions with similar characteristics. The parent function is y equal x, but that's written in standard form. If I want to write this in function notation, replace the y with f of x. So f of x is the y or the output equals the x. Now, if I want to graph this, make a table where x and y are the same because y equals x, or fx equal x. So when x is 1, y is 1, x is 0, y is 0, x is negative 8, y is negative 8. Plot them, then draw a line through it. That's the original or the parent equation. The parent function f of x equal x, where the slope is 1 because the coefficient of x is 1, and the y-intercept is 0 because you're not adding anything to it. So the graphs of all other non-constant linear functions are a transformation of the parent function. So any other equation you talk about is a transformation. And we will be talking about how did that parent function change through transformation. Okay, now the first transformation is translation. Here's the parent function f of x equal x, and it's already graphed. Let's use a transformation by adding a constant to the output. The output is the f of x. So the new equation y equal f of x, which is the output, plus 8. For you to do that, to graph it, let's make a table where x is 0 or negative 2. For the parent function, if x is 0, then f of x is 0. But since the transformation is adding 8, then 8 plus 0 is 8. When x is negative 2, the parent function f of x will be negative 2, but I'm adding 8 to that negative 2 or to the output, then you have 6. Now let's take x and y and graph them. Then put a line through it and name it a new function, like g of x equal f of x plus 8. watch what happened. That's a vertical translation. See how it went up. So when you are adding a constant more than 0, that's a vertical translation. Remember, vertical is the y, so you're changing the y by sliding it up 8 units. Now, what if you have f of x equal x, which is the parent function? Now let's transform it by subtracting a constant from the output. What if I subtract a constant from the f of x? Again, make a table where x is 0, f of x will be 0, but this time subtract 8 from the f of x. Then you get -8. And if x is -2, then f of x is -2, but because the transformation is to subtract an 8 from the f of x, then you end up with -10. Graph it, and that's the red line. Name it a different function, which is t of x equal f of x minus 8. Watch how this is a vertical translation, but this time down. So adding or subtracting the constant k to the output f of x is a vertical translation. The slope's still the same, but the y-intercept has changed. Now let's use the parent function f of x equal x and transform it by adding and subtracting to the input or to x. So you have a new function, y equal f of x plus h. Watch how it's in parentheses in front of the f. Here's the graph. Make a table where x is 5, 0, and -5. Now x is going to change by adding a 5 to it. So y equal f of x plus 5. So let's add 5 to it. Then the x becomes 10, and the f of x should be 10. When x is 0, add 5 to it, it becomes 5. So the f of the x plus 5, or the y, is 5, and so on. Now graph it, put a line through it, name it g of x, which means a new function, equal f of x plus 5. Watch how this is a horizontal translation going to the left. Now let's subtract from the x. When you have y equal f of x minus h. So let's subtract 5 this time. Make a table. Here's x is 5. Subtract 5 from the x, you end up with 0. So the f of x will be 0. If x is 0, subtract 5, that gives you -5. So the f of x minus 5 is -5. And so on. Now graph it. That is a horizontal translation to the right. Adding or subtracting the constant h this time to the input x is a horizontal translation. The slope is the same, but the y-intercept change. Now let's take the equation f of x equal x plus 4. Here's the graph for it. It's already been translated up 4 units from the parent functions. So there's already done a transformation by sliding, and you end up with the f of x equal x plus 4, right? Now let's change the sign of the output. Change the sign of f of x. So the new equation would be y equal negative f of x. To write that equation, it will be g of x negative, and replace f of x with the equation x plus 4. Now make a table where x is 5, then the f of x is x plus 4, but now I need the g of x, which is negative of f of x, so it's -9. When x is 0, the f of x would be 4, because 0 plus 4 is 4, but I need the negative of that to create the g of x, and that would be -4. X is -5, the f of x would be -1, but I need the negative of that, and negative of a negative is a positive, so the g of x, or the new one, will be 1. Now graph it by putting the dots using x and gx, and graph it, and this is where you will end up, and that's a reflection in the x-axis, because reflection in the x-axis is to change the sign of the y, or the output. X stays the same, and y changes its sign. To check if the reflection is right, make sure that the distance to the line of reflection is the same as the new function. Now let's take the same equation, f of x equal x plus 4. Now we need a transformation by changing the sign of the input, so we only change in the x. to write the new equation y equal f of negative x in parentheses because it's only the x, not the f of x, just the x. Write the new equation t of x equal, watch how I'm taking the x but changing its sign, plus 4. Reflection, if you remember, over the y-axis, the y stays the same and the x changes its sign. So since we're changing the x, it's a reflection over the y-axis, but I'll show you that. Now let's make a table where x is 5, 0, negative 5. Now I need the negative of x. So every x, make the negative first, which is negative 5 instead of 5. And now add 4 to it, gives you negative 1. If x is 0, negative 0 is still 0. 0 this should not have a sign. Plus 4 is 4. The last one is negative 5. I need the negative of negative 5, gives me 5. Add 4 to it, gives you 9. Now let's graph it by using the x and the t of x. So the t of x, once you graph it, here's the line, the red line, name it t of x, so that's the transformation. Watch how this is a reflection in the y-axis. To check, make sure the distance to the line of reflection is the same as the new function. Now let's take this to practice and see if we can describe the transformation and graph it. Here's the equation f of x equals 3x plus 1. The transformation is g of x and h of x. Watch or notice the difference. F of x minus 2, that means f of x is the output. Since we are subtracting 2 from the output, y, then it is a vertical translation down to a unit because you're subtracting. If you wanted to write the equation of the new g of x, it would be 3x plus 1, which is the whole f of x minus 2. Here's the graph. Watch how the g of x slide down 2 units. Now the second one, h of x, watch how f and then the x in parentheses by subtracting 2. So that's a change for the input x. Since we are subtracting 2 from the input, then it's a horizontal translation 2 units right. Hint, take the opposite sign when describing horizontal translation. Since you are subtracting 2, then you're going to the right 2 units, and here's the graph. If you wanted to graph it, to write the new equation so you can graph it and make a table, then the h of x equal 3 times x minus 2 because it's only the x that changed. So the x is what I put it in parentheses, not the whole thing, plus 1. And here's the graph, and you can see the translation to the right too. Here's another example to describe the kind of transformation. F of x equal negative 4x minus 2. The new transformation is the g of x and the h of x. So we're going to describe what happened to both of them. The g of x is the negative of f of x. Again, if you're using the whole thing, f of x, that's the y, that's the output. Since we are changing the sign of the output, then it's a reflection over the x-axis. If you want to write this down as an equation so you can graph it, the g of x equal the negative, in parentheses, all f of x, which is negative 4x minus 2. To graph it, here's the graph. It's a reflection over the x-axis. It's a flip. Now, h of x is f, in parentheses, negative x. So you're changing the sign of the x, which is the input. Since we are changing the sign of the input, then it's a reflection over the y-axis. So if you want to write the equation for you to graph it, then the h of x equal the negative 4 stays the same. It's the x that changes its sign, so I put negative x, then minus 2. And then you can graph it and watch how it is a reflection over the y-axis. Thank you for listening to the first part of the video that explains translation and reflection. The next part, or the second part of the video, will explain the vertical and horizontal shrink or stretch.